All right, so day 4, the last day of this lesson, quadratic functions in factored form. So now we're going to start with some word problems. So it says Marco hits a golf ball into the air from the 3rd level at a driving range. And then you're given the function there that represents the height of the ball depending on how many seconds have passed after he hit the ball. So if we're talking about that in terms of what the graph might look like, if I just did a quick sketch of a graph of the height, well, the height would start somewhere like here because he's on the 3rd level when he hits the golf ball. And then when he hits it, it kind of arches upwards, so it gets to a higher level, and then the ball comes back down and hits the ground. Now, the question is asking you when will the ball hit the ground. So by asking you when the ball will hit the ground, what that means what it's looking for is the x-intercept down there, or when the height is equal to 0. So if we want to know when the height is equal to 0, then we need to take the problem that you're given and set it equal to 0 and solve it. So we're going to do that. We'll take this problem, set it equal to 0, and then factor in order to solve it. So you always want to look for a greatest common factor. That should always be your first step. And if you look at the 3 numbers, 16, 32, and 48, the greatest common factor is 16. So I will factor out a 16. However, since it's a negative in the front, that means you're going to factor out a negative 16. And then when you divide everything, you will get t squared, and then 32 divided by 16, so minus 2t, and then 48 divided by 16 is 3. Again, still equal to 0. Now the 16, you will end up just dividing both sides by negative 16. So when you divide 0 by 16, that's still 0. So basically the 16 does nothing. Now we just take what's left in the parentheses, factor that, and solve. So this one's factored using product and sum, and it ends up being t and t in the parentheses, and I think the 2 numbers we use are negative 3 and positive 1, because those are the numbers that multiply to negative 3, but when you add them give you negative 2. Again, equals 0, and you are using the shortcut, which is to just change the signs. So you get t is equal to positive 3 and t is equal to negative 1. Now, there's only one possible answer to this problem, even though we just solved and got 2 solutions. Out of these 2, the one that's actually the answer is t equals 3. The reason why negative 1 cannot be the answer is because you cannot, or t represents time, and you cannot have negative time. So then 3 seconds is how long it takes for the ball to hit the ground. The second problem, it's the exact same thing. Set it equal to 0, factor, and solve. I'm going to skip that just since it's literally the exact same steps, just different numbers. All right, the positive and negative intervals. So if we're looking at graphs, any graph, even a parabola or something else, positive interval is any time the graph goes above the x-axis up here, and a negative interval is anytime it goes down below the x-axis. So if we want to figure out where are the positive intervals and where are the negative intervals, we can pretty much get a good picture of the two if you just figure out where does it cross that x-axis, because anything above the x-axis is positive, anything below is negative. So if I can find the x-intercepts, that will let me find the positive and negative intervals. And how do I find the x-intercepts? Well, that's just finding the zeros. So set it equal to 0, and you factor and solve. So this would factor into x plus 1 times x plus 2 And so you get the x-intercepts are -1 and -2. Okay, so then you graph these 2 points, -1 and -2, and then you draw a parabola that goes through there. Now we need to know if the parabola opens upwards or downwards. Even though we're doing just a quick sketch, we at least need to know that part. And so what you look at is the first term, because right there, that one, since it's a positive x squared, since it's positive, that means it's going to open upwards instead of downwards. So then the parabola looks something like this. Not the best drawing, but it's enough to get it done. All right, so the positive intervals are going to be anything above the x-axis. So looks like this part and this part. So then let's start with that. The one on the left is from -infinity up until you get to the -2 x-intercept that's positive. Then once you go to -2, it'll be negative because it's down here. Then once you go past -1, that's where it's back to being positive. So from -1, and then everything past there in this direction is going to be in the positive area. So then positive infinity. The negative interval is going to be everything that's below the x-axis, which is this part right here. So let me just write an interval for that. Well, it starts at -2. That's where it switches from positive to negative. And then it stops being in the negative part when you get to -1. Okay, I'll do the same thing on the second one. So find the x-intercepts, set it equal to 0. We will factor this into 2 parentheses. So this would be x minus 8 times x plus 7. They multiply to 56, and they add to give you the -1 in the middle. So you get x is equal to 8, and x is equal to -7. Now, my graph doesn't have 8 on here, so I'm just going to, it's really not a big deal in terms of what it looks like. You just need to know the numbers. So let's just call this -7, and we'll call this 8. And then, so then the parabola, again, this one opens upwards because it's a positive 1x squared. So parabola looks kind of something like this. The positive interval, so if you look over here, it's positive on this side. So it's positive from -infinity up until you get to -7. Then when you get to -7, that's where it starts being in the negative region. So therefore, I'll write the -7. It stops being negative though once you get to here at 8. So at 8 it stops being negative, and that's where it starts being positive. And then it keeps being positive for everything after that. Okay. The third one, it's the same exact thing. Factor it. This one would factor into 3x plus 8, and this one would be 3x minus 8. So it'll be decimals, but that's fine. You really just need to have a general picture. Okay, so this next example, what we're doing here is they are giving you the answers to a problem, and we need to write the equations that have those as the answers. So in other words, by them telling you that you have zeros at 2 and -1, they're essentially just telling you that x is equal to 2 and x is equal to -1. And we want to figure out what equation had these answers. So if we are working our way backwards, well, remember, so it'd be easier if I just had an example. Here, I'm just going to come up with a random one. Let's say you had x squared plus 7x plus 10. If you factored this, it would be x plus 2 times x plus 5. And then you would get that your answers are x equals negative 2 and x equals negative 5. So what we're going to be doing then with this is now we're going to go from here back to this and then back to the original equation on example A. So the last step that we did down here to go from x plus 2 to x equals negative 2 is we just change the signs, right? So let's do that on this problem. Let's just change the sign. So now it'll be x minus 2, and now we can place it in parentheses. And then with the x equals negative 1, same thing, change the sign, you get x plus 1. And then you're going to multiply these two together. So first, x times x gives you x squared, and then x times the 1 gives you 1x. And then you continue doing that. Negative 2 times x is negative 2x, and the negative 2 times a positive 1 gives you a negative 2. Combine the like terms in the middle, and you get x squared minus 1x minus 2. And there you go. That is the equation that has answers or solutions or x-intercepts or zeros at 2 and negative 1. Now the long way for doing that, I showed you a shortcut to go from the answer to the parentheses. The long way is when you have the x equals negative 1. In order for any of this to work, it all has to be equal to 0. So even the answer would be equal to 0. So if we want the x equals negative 1 to equal 0, you have to add 1 to both sides. And then that's what gives you that x plus 1 that we use in the parentheses. I'm going to use that to explain the ones that have fractions on example C and D. Okay, but let me just start with another simpler example just like this one. So 0's at 4 and negative 7. That tells you that the solutions are x equals 4 and x equals negative 7. And then, so to put in parentheses, shortcut is to just change the sign. And on the 7, also change the sign. And then you're going to multiply these two together. You end up getting x squared plus 7x minus 4x minus 28. And combine the middle two terms, and you get x squared plus 3x minus 28. And then again, it was equal to 0 that whole time, but we just care about the equation. The next examples, C and D, those are a little bit trickier. So we're basically going to have to do something like this. So we have x equals 1/2. And in order to change that back, what we're going to do is we're going to multiply both sides by 2. Multiply by 2 on both sides. And what that's going to give you is it'll now give you 2x. And then on the right side, 1/2 times 2 is just 1. And then, again, this needs to be equal to 0. Just like up here, we wanted this to be equal to 0. So on the 2x equals 1, what we're going to do is we're going to minus 1 on both sides. So now you will get 2x minus 1 equals 0. And so that is going to be one of our parentheses. Now we'll do the same thing to find the other parentheses. So we'll start with the x equals negative 2/3. We will multiply both sides by 3, so that'll give you 3x and negative 2. And then you add 2 to both sides, so you get 3x plus 2. That was an ugly 2. I'll fix that. Equals 0. and then there's your other set of parentheses. So now let's go off to the side and actually do the problem now. So 2x minus 1 times 3x plus 2. Multiply these together, you get 6x squared minus 3x plus 4x minus 2. And combine the middle two like terms, so you get 6x squared plus 1x minus 2. And there is the equation that had the solutions they were looking for. I'll do another example, but I'll go a little bit quicker. So the negative 5 halves, negative 5 over 2. When you convert, you get 2x equals negative 5. Add 5, so you get 2x plus 5. That's going to be one of the parentheses, because now it's equal to 0. Repeat the same process with the 1/4. So x equals 1/4. Multiply by 4 and subtract 1, so you get 4x minus 1 equals 0. So that's our other parentheses. So 2x plus 5 times 4x minus 1. Multiply these together, you get 8x squared plus 20x minus 2x and minus 5. Combine the middle two like terms, so final answer 8x squared plus 18x minus 5. Okay, so that's how you write an equation when you're given the zeros. Now, the next example, we're going to do the same exact thing. The only difference is with these problems, we wrote the most basic equations that had these answers. So like on B, for example, we wrote the most basic equation that had an answer, a solution at 4 and negative 7. The only thing is there's a bunch of different equations that can have those same answers, those same zeros or x-intercepts. The difference between all the equations that have those same x-intercepts is they have different stretches or compressions. So some of them are taller, some of them are shorter. So now we're going to, these are basic equations. Now we're going to do ones that are really, really specific. So we have, this problem says write an equation of a parabola with x-intercepts at negative 3 and at 3. And then you have another point somewhere on the parabola at 1, 2. So what we're given here is you have x equals negative 3 and x equals positive 3. Repeat the same process just like we just did on the last problem. So you'll just change the sign so you get x plus 3. And on the other one, change the sign, you get x minus 3. Now, we do not know whether this problem has a stretch or compression, right? So that means there is some multiplier, we'll call that a, that's in front of those x-intercepts. That now makes this an equation that has some kind of stretch or compression. Okay? Now, in order for us to know the exact equation that has those x-intercepts and also crosses through the point 1, 2, we need to figure out what a is equal to. Well, if we're going to figure out what a is equal to, then we're going to use that 1 and 2 for x and y to figure out what a is equal to. So I will do that. So plug in a 2 for the y and plug in, let me zoom in a little bit, and plug in a 1 for both of the x's. So 1 plus 3, and on the other one, 1 minus 3. And then you'll solve this. So you get 2 equals a And then you'll have 4 for this parentheses and -2 for this one. Multiply those two numbers together and you get -8. So I'll write -8a equals 2. And then divide both sides by -8. So divide. So you end up getting that a, I'll write on the other side, a is equal to -2/8. Do not change this to a decimal. I want you to keep it as a fraction, but simplify it. So both of these are divisible by 2, so it'll simplify to be -1/4. So then that means that the equation is going to be y equals -1/4 times x plus 3 times x minus 3. Notice how I just took this problem and rewrote it, but now with the -1/4 replacing the a. Now, since I was able to solve it. Now, from here, ideally, you would multiply all of this together. So you would distribute the x plus 3 times x minus 3, and then you multiply by 1/4. But for the sake of saving time, let's just call this the answer. I meant to do that in blue. Okay. So now let's do the same thing on another example. So x-intercepts at -2 and -1. So that tells me x equals -2, x equals -1. I will change these to parentheses, right? So x plus 2 and x plus 1. We don't know if it has a stretch or compression or a reflection, so we're just going to have that multiplier in front. Because that number in front, the a always tells you whether it's a stretch or a compression, or neither. And whether it's reflected. So then I will use the other point that they give you that's on the line, or on the parabola somewhere, for my x and y. So plug in the 20. We don't know what a is equal to, but we do know x is -3. So I will plug that in for both x's. And then I'll figure out what that gives me. So let's see, let's simplify this as much as we can. So -3 plus 2 is -1. And the other one, -3 plus 1 is -2. So multiply these two together and you get, let's see, -1 times -2 is 2, so 2a. Then divide both sides by 2. So you end up getting a is equal to 10. So now we can take this equation that we had started and actually replace the a with what we just calculated. So your equation is going to be y equals, we know a is 10 now, and then x plus 2 times x plus 1. Now, I would accept this answer, but just to show you what would happen after that, if you really wanted to simplify this as much as possible, you would take the x plus 2 and the x plus 1 and multiply those together. Well, I'm going to do that quickly in my head though. When you multiply x plus 2 times x plus 1, you get x squared plus 3x plus 2. And then this would be multiplied by the 10. And then, so final answer multiplied completely out when you distribute out the 10 gives you 10x squared plus 30x plus 20. So that is the completely, how should I say, called or completely simplified in standard form and all that fun stuff. All right, so that's the end of section 2.3.